Hi, hey Gidara. Welcome back to the session. Bridge Course Chemistry session number 3. My name is Adil Khan. I'm your chemistry teacher at Base Education Services. Before we move inside session number 3, let's start with the question of the day of the session number 2. And first, let's answer that. Session 2 question of the day. The very first question. What is the valency of the cuprous and the cupric ion? So they both are made up of copper. So the formula is Cu and the formula is Cu for this also, but not exact one. I'll tell you the exact one also. In the previous session, I have given you a cheat code to remember, and the cheat code was LOWUS. LOWUS means lower oxidation state, means the number +2, +3, +4. So the lower oxidation state end with us. Now here us is there, so it will have a lower oxidation number, that is the charge. So this is +1 and this is +2. So you can even write like this, 2 plus charge. So this is your cuprous. +1 is a lower charge, that's why us, whereas cupric is the higher charge, that's why it is +2. So it is Cu plus and Cu2 plus. One extra information for you, cuprous ion, they produce colorless substances, whereas cupric ion, they produce green color or sometimes slight bluish color compound or substances, just for your knowledge. Second question, what is the formula of sodium hydrogen carbonate? The name only suggested that there is a sodium, there is hydrogen, and carbonate is CO3. Carbon dioxide is CO2, carbon monoxide is CO. This is sodium hydrogen carbonate. This is the formula. How to get this formula? Basically, your sodium is a Na plus, that is the cation, what we discussed in the previous session, and carbonate is minus. So when you do a crisscross, this +1 charge and -1 charge, they are of similar magnitude, that is +1 and -1. So we don't write that number. So you get this formula as NaHCO3. Couple of additional information about sodium hydrogen carbonate, that it is also known as, one common name is there for sodium hydrogen carbonate. Do you know what is the name? You use in idli, dosa, cake, batters. Correct. It is also known as baking soda. So sodium hydrogen carbonate, the another name for this is your baking soda. And it is also used in fire extinguisher. Why it is used in fire extinguisher? Because when it reacts with some acid, it produces carbon dioxide. And this carbon dioxide gas is a non-supporter of combustion. It doesn't help in burning or catching fire. So it is used in fire extinguisher, just for your knowledge. Third, write the formula of potassium nitrate. So here again, the concept applies the same. Potassium is K plus ion and nitrate is NO3 minus ion. So when you do crisscross, the magnitude remain the same, +1 and -1. So what you get? Potassium nitrate as KNO3. Couple of additional point about KNO3, that it is an important fertilizer used by the farmer. Why? Because it helps in increasing the efficiency of soil by increasing the retention capacity of water. So it helps the soil to retain water. That's why the efficiency of soil increases, KNO3. You also use potassium nitrate during our festival known as Diwali as a firework. In the firework, the fire, what you use, no crackers, it is present in that, in the firework also, potassium nitrate. It is also a type of food preservative. For example, your Lay's and Kurkure packet, they contain either argon or nitrogen gas. Argon or nitrogen gas as preservative. Similarly, KNO3 is also used as preservative in various other substances. Next question, why is the name given as basic radical and acid radical? If you remember in the last class, I have given you a cheat code. Basic radical and acidic radical, I can say that they are another name for your ions. So radical means ion in a generic way. So basic radical cheat code was basics are always positive, whereas acid radicals, they are negative. So this is positive means cation, this is negative means they are anion. The basic radical, when you talk about that, what is your basic radical basically is that it helps to accept H plus ion. So here it accepts H plus ion. That H plus ion comes from acid. So since the name suggests base, so bases they accept H plus ion. That's why basic radical they accept H plus ion. That's why the name basic radical is given. There are a couple of more reasons, but this is the standard one what I am quoting. Next one is what is acid radical? Again, it is opposite of basic radical. Basic radical accept H plus ion, whereas acid radical they donate H plus ion or lose H plus ion. So this negative sign what I have written here, this one, it means the H plus ion is going out. So here H plus ion is accepted, here it is lost. That's why that is basic radical and this is acid radical. And according to Arrhenius theory, your acids are those which produces H plus ion. So that concept is also, I think, you know. The last question from the previous session, that why water formula is H2O, not OH2. The reason for that, we always write electropositive element first, followed by electronegative element whenever we find out any formula. Hydrogen is electropositive. Electropositive and oxygen is electronegative. What do you mean by hydrogen electropositive? That it can lose electron easily. If you are electropositive, you can give out electron and become positive charge. If you are electronegative, you accept electron and become negative charge. So while writing any formula, we always write positive first, followed by the negative. That's why we write hydrogen first, followed by oxygen. Similarly, sodium chloride, you never write ClNa. This is a wrong representation. Rather, the correct one is NaCl. Why NaCl? Because sodium is electropositive, it donate electron, and chlorine is electronegative, it accept electron. So always you write electropositive element followed by electronegative element. That's the concept which we use there. So that's all from the previous class question of the day. Let's move to the next session, the session number 3. Let's start with something interesting. And I am feeling hungry. Are you also feeling hungry? What do you snack when you feel hungry, guys? What's your favorite thing? Anyone write like BP? Hey, not basic positive, yeah, neither blood pressure. BP. You'll get to know what is BP. BP. This is your BP. What is this? Bhel puri. Ek number. Very good. Correct answer. Now, what is bhel puri is? Basically, it is one of the famous Indian snack. What we consume whenever neither we are too hungry or too full. It is made up of puffed rice. It is made up of tomatoes, onion, spices, corn flask is there. Then it is made up of save. Then you put coriander, and in presence of some sort of oil for garnishing, you mix it and you eat it. It tastes yum with multiple Indian flavors inside it. Bhel puri in chemistry explains which concept? Bhel puri is what? You go and tell, no, Anna, give me one mixture of bhel puri, right? One mix of bhel puri. So using bhel puri, we are going to discuss the concept of mixture. So bhel puri is an important type of mixture. So the going forward in pipeline, we have mixtures, we have type of mixtures, then we have compounds. Then we have physical property, chemical property. Then we have atomic masses, molecular masses with example. That is the pipeline of this session. I like it. Thank you. Let's move forward. Now, what is basically mixture is, suppose I give you the example of bhel puri only. It is made up of puffed rice, tomatoes, onion, coriander, spices, masalas, oil, save, cornflakes. Now, if suppose from bhel puri, you pick one cucumber and try to eat, or one tomato piece and try to eat, can you taste tomato and cucumber there? Correct. When you take the puffed rice and eat, will you feel the flavor of puffed rice with some masala there? Correct. Mixture is that. Mixture is what basically you are doing a mechanical blending. You are not doing any chemical reaction there. So mixtures in short is, they are those compound or substance which is produced using some constituent particles, like that's corn flask, save, puffed rice, like that, by just mechanical mixing in any proportion of ratio. For example, if you eat bhel puri in North India, then they most of them like sweet. So they will put lot of tamarind chutney and tomato chutney inside it. When you eat down south, somewhere in Hyderabad where they like spices and all, then they will add more of the dhania chutney where it is a bit of spicy in flavor. You can increase the amount of puff rice, you can decrease the amount of puff rice, you can increase the amount of tomato, decrease. So there is no fixed ratio to prepare bhel puri across India. They use according to their convenience. And if suppose you go to a bhel puri shop and you tell you give me bhel puri and you don't like tomatoes, still the person put tomato, you can remove the tomato and eat. So you can separate also mixtures using mechanical method like hand picking, filtration, chromatography, sedimentation, etc., etc., etc. Now let's see a couple of standard definition. Mixture, it contains two or more substances or compounds which are physically mixed or just blend. Physically mixing is there, no chemical interaction in any proportion by mass. You can use any variable proportion, no fixed proportion. The properties of mixtures are same as the properties of the constituent. For example, in bhel puri, when you consume 1 spoon of it, you can taste flavor of everything: puffed rice, tomatoes, onion, cucumber, everything. It's not like that. When you mix them, you get a different flavor. You're not getting a different flavor. It's a mixture of all the flavor. That's why this line, the properties of the mixture are same as the properties of the constituent. So whatever is the flavor of the constituent, same the product will give you. The constituent of a mixture can be separated by some physical method. You can pick with hand or any other simple physical method. So example of your mixture is air. Air is made up of oxygen, nitrogen, hydrogen, carbon dioxide, water vapor, some bacteria, viruses, dust, smoke, smog, everything. So it's a mixture. Soil also, it is made up of clay, it is made up of slate, it is made up of pebbles, it is made up of organic manure. Trail mix of mud, nuts, basically it's what you can take cashew, walnut, some berries you can add amla to it, gooseberry, and make it. So they all are example of mixture. So mixture in short is that it is made up of those constituent particles. It is made up of constituent particle by simple mixing, no chemical interaction. And the final product, that is the mixture, will contain the properties of all the constituent particle, and you can separate it using any physical method. This representation you see, this is the example of your mixture. In mixture, when you see, you have two different type of constituent particle or balls. So this is dark green color and this is light green color, dark green, light green, like that. So this is called as mixture. If suppose you want to remove this dark green color, you can remove by any physical method. If you want to remove this light green color, you can remove it. Now that is mixture, and it is made up of light green color ball and dark green color ball. So here my light green color ball is example of my pure substance because it is only made up of light green color ball, nothing else. Whereas my dark green color ball is also example of my pure substance because only dark green color balls are there. You don't have anything else. So one pure substance mixed with another pure substance to give you mixture in any fixed ratio. For example, I am using 6 balls here and 6 ball here. There is 6 plus 6, 12 balls. I can use 4 ball here and 6 ball there to make it 10 ball there. It is still mixture. I can use 2 ball here and 8 ball here to make 10 ball there. It is again the same thing. And you can easily separate also. So this is example of your mixture. Mixtures are of two important type. One is homogeneous mixture and one is heterogeneous mixture. Let's go and discuss that part. Before we move in, let's see one diagrammatic view of type of mixtures. So one is homogeneous and one is heterogeneous. The word homogeneous is a Greek word which means homo. From this word only we got the word modern Homo sapiens, for we human. Modern Homo sapiens in biology. So homo means same and genus means basically the constituent. So same type of constituents are there. The word hetero in Greek means different. So that's why you can see difference here. So this is your black coffee. Your black coffee is made up of water. It is made up of sugar or the jaggery cube, and it is made up of coffee powder. So when you mix them and you heat them ultimately on some heating source, you will be getting this delta sign represent heat. Okay, you will get coffee. Now in this homogeneous mixture coffee, black coffee, can you find out where is water? Can you tell this is my water layer? You can't. Can you tell my sugar is here or jaggery is here? You can't. Can you tell my coffee powder is here? You can't, because you cannot differentiate between these three constituent. Water, sugar, and the coffee powder, this is completely mixed. So this is homogeneous, means you cannot differentiate between water, sugar, syrup, and constituent particle. There is no boundary between all these three constituent particle. Here in heterogeneous mixture, you have a, you can say it is just like muesli or your corn flask bowl. So here you have milk. Here you have strawberries. Here you have corn flask. Here you can even have dry fruits. Or let's avoid the dry fruit part. Suppose three only. So three constituent particles are there: milk, strawberries, and corn flask. Now inside this, your strawberry is clearly visible. Your milk is, this is milk, this is strawberry, and this is your corn flask. It's completely visible, right? So there is a clear cut boundary. You can pick one piece of strawberry and taste it. You can pick one piece of corn flask and taste it. So there's a clear cut boundary. So heterogeneous mixture boundary is visible between the constituent particle, and it is not uniform composition. Maybe the lightweight corn flask, they will float on the top, but they will not be in the bottom. Maybe the strawberry, which is heavier, they will sink down and the bottom. So corn flask is float on top, strawberries will go on down. So basically in this case, a clear cut boundary is visible, and you can easily find out where are the constituent particle. So this is the major difference between homogeneous and heterogeneous mixture. Let's go and see in the definition format. Type of mixtures, there are two types, homogeneous and heterogeneous mixture. So in homogeneous mixture, the component have uniform composition or distribution throughout. Just like your, I took example of your, kya liya tha? That black coffee. Now distribution throughout. So example is salt and water, sugar and water, alcohol and water, etc. They all mix. When you add salt and water, you cannot differentiate where is salt and water, where is sugar and water. One quick question to you. Between salt and sugar, what do you think which is more soluble in water? Correct. Salt is more soluble in water. The reason? Find out. It is hidden in the bonding, which type of bond they are. Heterogeneous mixtures, in this the component do not have uniform distribution. They are completely visible. The boundaries are visible throughout the mixture. Example, sand and water. When you use sand and water, sand will settle down in the bottom, water will float on the top. It will be a dirty water. Sugar and salt, again differentiation will be there. The sugar crystals will be big, the sand crystals will be small. Salt crystal. Ice in water at 0 degrees Celsius, you can differentiate the ice cube and the water, but as the temperature increases, ice melt and it become part of water only. So in homogeneous mixture, there is a uniform distribution, no clear cut boundary is seen. Heterogeneous mixture, no uniform distribution, and sorry, I will repeat again. Homogeneous mixture, uniform distribution, no clear cut boundary. Here, no uniform distribution and a clear cut boundary is visible of those substances what make that mixture. Now let me give you a live demo of this. Now here I have one beaker of water. This is 200 ml of water in a Borosil beaker. And here I have your table salt, that is NaCl, which is white in color. White in colorless is same in chemistry. So I am adding maybe couple of grams of it, and I will use my spatula or spoon or mixing substance to mix it like this. A couple of round of mixing is done. Can you differentiate where is water and where is salt? You can't differentiate. It is uniform. Uniform distribution is there. You cannot differentiate between salt and water. So which type of mixture is this? Homo or hetero? Correct. It is your homogeneous mixture. Heterogeneous mixture, I am taking a different beaker. See, this is my salt and water wala beaker. Okay, I'm keeping it aside. This is my different water beaker with around slight more amount of water. I'm adding sand to it, around couple of grams of sand to it. Same method, I am mixing it using my spatula. Suppose same round of mixing, I am doing it. When I do all this now, can you see? Dirty water on the top and bottom, you can see the sand is settling down. So there is a clear-cut difference in the boundary between the water and the sand, and there is no uniform distribution. Why it is like that? Why salt is soluble whereas sand is not? It's hidden in the bonding, ionic and the covalent bonding and the stable structures and all that you will read with time. So I hope this is clear for you. Before I move inside, I just want to ask you, you know stainless steel? I believe you know stainless steel. What is this? Is this homogeneous mixture or heterogeneous mixture? What do you feel? Homo or hetero? Homo, correct answer. Blood, homogeneous or heterogeneous? What do you feel? Our blood, human blood, homogeneous or heterogeneous? Quick. What do you feel? Homo, wrong, heterogeneous, because blood is made up of WBC, RBC, red blood cell, white blood cell, plasma and platelet. And when you see under the microscope, the clear-cut boundary differences are there. So this is my homogeneous mixture and this is my heterogeneous mixture, just for your knowledge. Now let's move to the next topic. Again, you will be feeling that sir is very hungry today. I am not. I am just giving the graphical diagrammatic view to make you understand things more clearly. This is nature. So blessed we are. So vibrant color. It is made up of some berry. It is made up of blueberries. Apple is there. Kiwi is there. You have, what is this? What do you call this? What do you call? No, pudina leaf. Then grapes is also there. Then various other things are there. And here you have a white color substance, which is nothing but salt, table salt, what you called it as sodium chloride. Which two concepts of chemistry I can explain using these two pictures? You are correct. That is mixture again, and this is compound. Mixture, compound, mixture, compound. Here you can see mixtures are visible. It is combination of various different type of fruits and berries. For example, apple, strawberry, you have raspberry, you have blueberry, you have grapes also here, you have some leaves also here. So clear cut boundary is there and differences are there. They are mixture. They are not mixed in uniformly. For example, if I want to make the fruit salad or fruit platter for myself and I like more of kiwi, then I will put more kiwi inside it. But if my friend is coming and I don't want him to eat kiwi, then I will tell kiwi is not there. I will put more of apple and papaya inside it. So mixtures, you can decide how much amount you are putting. It's not uniform or standardized. But when you talk about compound, for example, NaCl, whether you are in India or Uganda, the formula of NaCl remain the same. One sodium and one chlorine. Similarly, whether you take water from Kaveri River or Ganga Ji or Yamuna Ji, or you take it from Brahmaputra, or you take it from Gandak, or any big river form in India, or you take the tap water or you take the borewell water, the formula of water remains same. It is made up of 2 hydrogen atom and 1 oxygen atom. So the ratio is fixed. So compounds, they are chemically mixed in some specific ratio. Mixture, they are physically mixed without any specific ratio. So let's go and see the difference between mixture and compound. So mixtures, they are just physically combined or blended, no chemical reaction. Whereas compound, they are chemically combined. For example, when you do the formation of water, then it is formed at a very high temperature in the presence of a catalyst and various other conditions. Mixtures, substances can combine in any ratio. I give you an example, no, that if I will prepare fruit platter and I love kiwi and my friend is there, I don't want him to consume the kiwi. I will remove all the kiwi and give him the fruit platter. So you can take any ratio for mixture. Whereas in compound, they always combine in a fixed ratio. For example, you burn paper, you burn coal, you burn wood, and you exhale out. What is common thing in all these 4 examples? That carbon dioxide is released. So carbon dioxide, it is made up of 1 carbon and 2 oxygen, whether you are in India or Uganda. The formula remains same. 1:2. 1 carbon is going to combine with 2 oxygen. Next, mixtures can be separated by physical method. You can hand pick and remove the choice of your fruit from the fruit salad. You can remove by filtration, by sedimentation, chromatography, and various other physical method. But compound elements can be separated by chemical decomposition only. For example, when you take water, you just don't tell water that, buddy, I don't want you to be together. Hydrogen, you come out, and oxygen, you please leave it. It will not happen simply like that. You have to apply some conditions there. So that is known as chemical decomposition method. So you cannot simply do it. For example, when you take any organic compound, I take methane and I mix with oxygen and I tell it you react, it will not react. You have to give some specific amount of heat. Then only it will form carbon dioxide and your water vapor. One important thing I will tell you now, this is methane CH4, that any organic compound you take it. For example, you take me and take my hair, or you take any other organic sample like plant, wood, or any human or animal organic sample. Whenever you burn organic compound, you always get four important things. That is carbon dioxide, water vapor, heat, and light. That's how the LPG work and the fossil fuel work for humankind. That's for your knowledge. Properties of mixture resemble to similar property of each constituent substance. Let me give you an example of fruit salad plate. That fruit salad plate, when you are eating one piece of apple and one piece of papaya, you can make difference between when you are biting apple and papaya according to the flavor. So even though the fruit salad is a mixture of various fruit and berries, still you can make out according to the taste which one is this fruit and which one is that fruit. So the mixture is made up, the mixture property is similar to the property of the constituent particle, but it never happens in case of compound. The properties of compound is different from the constituent particle. For example, if I give you sodium chloride, sodium can cause fire. It is very explosive in reaction. And chlorine is a, basically I'm writing in atomic form. I'm not balancing in all, not at present. So chlorine is a greenish yellow color gas. So they both are not good for humans. You can tell that both are poisonous and toxic for us, harmful for us. But when they combine, it forms sodium chloride. And if you don't eat this sodium chloride, it will be harmful for your body because your nerve, your muscle contraction and all part, they depend on the salt intake also. So individually, when they are not good for human, when they combine, they are good for human. That is the meaning of this. Property of the compound is different from the property of the elements. Similarly, I think I have given you this example also. When you take water, I'm not balancing, guys, okay? It is made up of hydrogen and oxygen when you take water. Now, hydrogen, when it burns pale blue in color. Oxygen help in burning. So they both are involved in burning process or combustion process. But water, when it form, this water will help to close down or shut down the fire or the burning process. So individually, when they support burning and they burn, when they mix, the product formed help to shut down the fire. That's the meaning of properties of compound is different than that of the constituent element. And your mixtures are impure substance. Impure substance means there is a clear cut visibility that it is made up of various different type of constituent particle or molecule or substances. Whereas in case of compound, it is the pure substance. When hydrogen and oxygen combine, it give water, which is liquid. You cannot find out where is hydrogen and where is oxygen in that. Similarly, when carbon and oxygen combine, carbon is a solid, whereas oxygen is a gas. It produces carbon dioxide or carbon monoxide, which is a gas. You cannot differentiate between which is carbon dioxide and which is carbon monoxide. Carbon monoxide is CO. This is known as silent killer for humans. Why it is known as silent killer? Find out the answer whenever I will meet you in future. I will ask on that why carbon monoxide is silent poison for us. So example of mixture is brine solution. Brine means salt solution, sugar water solution, whereas brine solution and sugar water solution. Why brine solution? Because when you heat the brine solution, no, water will evaporate, the salt will remain back. You can separate it. Sugar water solution, when you evaporate water on heating, the water escape as vapor and the sugar will stay back there. Here example is sodium chloride and calcium carbonate, CaCO3, which is limestone or your marble formula. It is also the formula of your egg shell. Now sodium chloride, when you heat also, no, it will not separate sodium and chlorine that easily because of the structure. Water and all is not here, so evaporation process is not there. So that is your mixture and this is your compound. So mixtures, basically they are formed by physical combination, and the substances can be mixed in any ratio. They can be separated by physical process. The properties of constituent particle and the mixture remain the same, and they are impure substances. Whereas compounds, they are chemically combined, chemically bonded, and always the reaction is in the fixed ratio only. And if you want to separate them, you need chemical decomposition type of reactions like heat, pressure, etc. And the property of the constituent particle and the compound formed is completely different, or they may have similar type of property also to some extent. And compounds are pure substance because in compound, you don't see the constituent particle often. It is completely bonded together. So a new entity is produced. So this is all from your mixtures and compound. I hope this is clear. Let's move to the next topic, that is physical and chemical changes. So one word is common between physical and chemical, that is change. What is change is, for example, this is my salt box and this is my, sand box and this is my salt box. This is 3 gram. If I am putting 1 gram here, 2 gram is left. The concept is known as change. 3 minus 1 is 2 gram is left the salt in one of the box. So change basically means what? That something is changed either with respect to temperature, pressure, state, whether it is solid, liquid or gas, or the molecular arrangement to some extent. This is known as change. There are two types of changes, physical and chemical changes. For example, if I take a iron rod, suppose this is my spatula, which is made up of a metal, and when I bend it, it is which type of change? It is called physical change, because it is still the spatula or iron rod or any metallic rod. I can make it straight again. Okay. So this is reversible in nature. So all this we are going to discuss now. Physical and chemical change. So when one or more properties of a substance is altered or changed, then it is said that the change has occurred. Two types of changes are there, physical and the chemical change. Just now I exhibited by bending the spatula, it is physical change. But when this spatula, which is, suppose it is made up of iron, undergo rusting or corrosion, then that rusting and corrosion is a chemical change. Bending is the physical change. So bending of metal is considered as a physical change, whereas corrosion or rusting is known as the chemical change. Iron, generally they undergo rusting. It is a process which is involved in corrosion topic. It form rust. Rust formula is Fe2O3.XH2O. It is a brown, flaky, sticky type of substance, Fe2O3.XH2O. This X means water of crystallization. So whenever an iron piece or an iron nail come in contact with oxygen and the moisture, it has to undergo rusting. There are various methods to prevent rusting. We will teach you when you come to the higher grades. So rusting is a chemical change, whereas bending of the rod is a physical change, just for your knowledge. Physical change, no new substance is formed. When I bend, it still remains the iron rod only. Here a new substance is formed. For example, when rusting takes place, rust is formed. This is the formula. Physical change, they are reversible. When you bend, you can again regain back the shape. Whereas chemical change, they are irreversible in nature. Once rust is formed, you cannot tell, hello rust, brother, I don't want iron and oxygen to be combined. You separate out. They will not separate out. They are combined. They combine chemically and they have a strong bond. For example, when you join our colleges and Ramesh and Suresh, if they are sitting together and they're talking in that class, I will tell Ramesh, you go to left side, and Suresh, you go to the right side and sit down. Which change is this? This is physical change, because the moment I go out and new teacher come, you will come and sit together like a magnet. We are friends. So Separating friends is also a type of physical change. Physical change, they are temporary in nature. It's not permanent. I gave you example of Suresh and Ramesh. No, it's temporary. Whereas chemical change, it is permanent. Sir, can you give one example of chemical change using Ramesh and Suresh example? I can. Suppose in the first year exam, the final exam, you don't perform good. We don't continue those students with us if you are not getting a passing marks for 12th standard. Suppose Ramesh will be staying in base and Suresh will go and join some other XYZ college. Now that is the chemical change. Even though you can meet outside college, but during the college time, you and your friend, you will never meet for next academic year. So just keep in mind. These are the few diagrams here. Just help me out which type of change they are. What is this combustion reaction, burning of wood, physical or chemical? Once you burn the wood, it form ash or coal. What is that? Correct. It is a type of chemical change. Rotting of apple. Can you remove the rot process? You can't. So this is also chemical change. Rusting, just now I explained it is chemical change. Suppose you eat today 2 medium-sized pizza. Your pizza is somewhere here located in your tummy. After one day, do you think pizza will be there? You can tell, hi pizza, how are you? No, it will not be there. It will be digested. So this is also a type of chemical change. Melting of ice cream. What do you think? Chemical or physical? You can again solidify it by keeping in refrigerator. This is physical change. Shredding of paper. Here also it is a bigger paper. This is a small piece of paper. Again, it is similar type of product. Physical change. Boiling of water. Water is boiled, that water vapor, what is coming, you collect and you liquefy it, again become water. The formula remains same, physical change. And when you cut or chop tomatoes and potatoes, it is physical change because this part is also tomato and this part is also tomato. So that side entire thing is chemical change and this side is your physical change. So the differences, no new substance is formed here. Ice cream, water remain the same, paper remains same, tomato remain the same. It is reversible in nature. You can solidify shredding things. You can join also using glue or other things. This chopping part you can join using something. You can stitch also. And here it is temporary in nature, whereas chemical change, they are permanent in nature. I hope this is clear to you also. The rusting part is important. So please remember that for your future concept. Now let's move to the next topic, that is chemical reaction, chemical equation, followed by atomic masses and the molecular masses. What is a chemical reaction? For example, whenever you will join base, whichever branch of base, when you are joining in somewhere in May, why you are joining is because your motive is you're coming out from X school, joining base, and you will go to Y college after your either medical or engineering college after your 11th and 12th exam. Then from 10th to 12th, there will be a transition in you as a person. You may grow as a student. Your attitude in life may change. Your risk-taking ability will change. Your note-taking ability change. Your answer writing skill will change. Your confidence you will gain. So one reaction takes place inside you. So what you were in the 10th standard and what you become in medical and engineering college, a reaction takes place. And this entire process is known as chemical reaction. So you in 10th standard and you in medical or engineering college, this 10th standard one is called reactant and this medical and engineering college is called product. And in between the 2 year of base is that arrow what we use, that is telling that what changes are created in you. That is a layman term explanation. Where is my pen? Oh yeah. So chemical reaction is representation of chemical equation. What is chemical equation is, you take reactant, you form product. What is reactant? They are those molecule or substances before the change is brought to it. And product, they are those molecule or substances after the change is applied to it. The change must be permanent change or temporary change, both. We are focusing on permanent. And reaction is represented by this arrow, forward arrow. It is also known as yield. Yield means produced. So reactant transformed into product or yield into product. That's the meaning of your arrow. Now a chemical equation. Now this entire reaction you can represent as an equation. For example, when I take sodium, when I combine with chlorine, I'm writing in a very layman term. it can form NaCl. So this is my reactant, this is my reactant, this is my product. And here are some specific conditions applied for formation of NaCl. So a chemical equation, this is the equation, is a shorthand representation of reactant and product when they are represented using their formulas or symbol or formulas basically. So chemical equation help to represent the reaction. Okay. So there are three things involved here. One is reactant, one is product. Reactant before the reaction start, product after the reaction stopped. And in between that arrow is the process what is taking place. And this entire reaction follow one important law known as LOCM. What is LOCM? It stands for Law of Conservation of Mass. What is Law of Conservation of Mass? That whatever is the amount of product, whatever is the mass of the sample at the start of the reaction, same will be the mass of the product after the reaction. For example, I take 1 kilogram of rice and I mix to it 1 kilogram of curd. So this is my rice and this is my curd. And finally, what I will form? Curd rice. What do you think? How much amount of curd rice will be this? 2 kilogram of curd rice. Correct answer. If suppose the amount of curd rice increases, I started with 1 gram of rice and 1 gram of curd, it becomes 5 kilogram of curd rice, then everyone will be in that business. If I start with 1 kilogram of rice and 1 kilogram of curd and it becomes 500 gram of curd rice, no one will produce curd rice. The best possible condition is 1 kilogram of rice and 1 kilogram of curd is giving rise to 2 kilogram of curd rice. This is known as law of conservation of mass, that whatever is the reactant mass, same will be the product mass, except radioactive reaction where mass loss is involved. So non-radioactive reaction, they follow LOCM, law of conservation of mass. A chemical equation is balanced in accordance with law of conservation of mass that state that the number of the atom of each element on the reactant side is equal to those of the product side. So this is telling with respect to the number of atom on reactant and product side. I explained you using the mass concept. Okay, both are accepted because the number only become mass after some time. So here couple of terms are there. You have reactant. Reactants, the chemical exists before the reaction. Product, the chemical produced after the reaction. And this is the arrow which represent yield or produces. So arrow means yield or produces or transformation also you can tell. And this number which is present here is known as coefficient. Coefficient basically is a number which tells that how many atoms or molecules you are using. So here I am using 2 molecules of water to produce 2 molecules of hydrogen and 1 molecule of oxygen. Whether you write one or not, it is self-explanatory. So this is stoichiometry. This is stoichiometry. Later I will teach you that it is also known as stoichiometric coefficient in the chapter of equilibrium. And this is a forward reaction, one arrow only. Some reactions you will see that 2 arrows are there. Okay, reversible reaction. It can be also represented like this. Equilibrium concept also we teach in this place. So total 4 things you are going to consider while writing a chemical equation. 5 things. First is your reactant. Second is your product. Third is your stoichiometric coefficient or coefficient. Fourth is your arrow, and fifth are the conditions or the situation or the condition, temperature, pressure, catalyst, whatever you have used, that part. So total 5 things you have to remember during a chemical reaction and chemical equation, and they follow law of conservation of mass. This number 2 even help you in balancing. Okay, that is again a big concept we will discuss when we go inside. Now, using the concept of chemical equation, when you write chemical equation, atoms are involved, molecules are involved. Now, whenever atoms and molecules are involved and you are doing a reaction, you must know how much atoms and molecules you are using during the reaction. Now, let's go back and discuss an important, very important concept of atomic and molecular mass. Now, just a sec, I am just removing my shoes. So atomic and molecular masses. Now, basically atoms, they are very tiny, chota, very small, very small. You cannot measure its weight, neither you can, simple word, they are so small that you cannot measure its weight. Now, how to find out the weight of atom then? For example, when you go to a vegetable vendor or a fruit vendor and demand that you give me 1 kilogram of apple, then what the vendor will do, he will take one weighing balance like this. Here he or she will keep a iron bar, okay, iron bar, and here 1 kilo iron bar, and this side he or she will keep 5-6 pieces of apple. And if the measuring balance, the weighing balance is just like this upright position, the needle, it means that 1 kilogram of apple is there. So what are you finding out? Are you finding out the exact mass of apple? Answer is no. You are not finding out the exact mass, rather you are finding out the relative mass of the apple. That 1 kilo iron gram, whether you are in India or Uganda, you believe that that is 1 kg. How you will believe? There is an association known as IPK in France. Okay. They have something known as iridium type of alloy cylinder, platinum iridium alloy cylinder of 1 kilogram sample. And using that sample in France, entire world get that iron mass of 1 kilogram. So we are basically finding out relative mass. We cannot find out absolute mass for atoms and molecules because they are too tiny and negligible in mass. So remember that no absolute mass, relative mass. Okay. Now let me take you further. So atoms and molecules, they are too small and they are too light to be weighed or measured. You cannot measure them. Now, scientists realize that one of the best way to express such small masses is using a relative scale like this weighing balance. Relative scale means how many times one atom of an element is heavier than that of another. So what are you doing? You are relating one sample with another standard sample. How many times one atom of an element is heavier than that of another. So there is a known mass and there is an unknown mass. So using known mass, you are finding out unknown mass. Now, what is this known mass? Let's go and find out. Okay. Now, let me give you an example. This is a cold coffee. Cold coffee, I am standardizing using your bread slices. So cold coffee is equivalent to 5 bread slices. I'm doing standardization. Similarly, French fries packet or French fries, this envelope is made up of 1, 2, 3, 4, 5, 6, 7. Standardized with 7 pieces of bread slice. So whether you are on Bangalore International Airport or Mumbai International Airport or Dubai International Airport, if standardization is done globally, 5 pieces of bread slice is equivalent to cold coffee and 7 pieces of bread slice is equivalent to your French fries. This is called as standardization. I know the mass of this, I am relating with this. I know the mass of this, I am relating with this. Basically, I know the mass of one bread slice. If suppose this is 5 gram, suppose 5 gram, this is 1 gram, 1 gram, 1 gram, 1 gram, 1 gram. So 5 gram LHS, 5 gram RHS part. So that 5 is balancing this 5. Law of conservation of mass is followed. So this is known as relative scale. In chemistry, we use a specific element as a standard element. Initially, we used hydrogen, but it failed due to various reasons. Then we used oxygen. It also failed due to various reasons like isotope and various other concepts. At present, since 1961, across the globe, globally, we use carbon 12 isotope as standard to measure other element. What do you mean by carbon 12? The word number 12 is the atomic mass basically. Carbon has various type of isotope. Do you know how many type of isotope carbon is having? 15. But your teachers and your book tell only 3, that is carbon 12, 13 and 14. Now we take carbon 12 isotope globally as a standard element. Why? 3 to 4 reasons are there. The first reason is they are highly abundant. They are present in huge amount in nature. We are also made up of carbon. This board is also made up of carbon, graphene. Books are made up of carbon. Trees are made up of carbon. So they are abundant. Second is their entire chemical properties are known to us. Third is they are less reactive, and fourth is we know its molecular structure. Due to this four reason, we use carbon as the standard measuring element for other atoms, okay, globally. Sir, you said hydrogen, oxygen fail due to isotope, but carbon, you said 15 isotopes are there. Hydrogen, oxygen failed. Another concept reason is that they are in gaseous form. And it is difficult to study the entire property of the gaseous element. That's why we stick to carbon 12 after 1961, and still we are following this. And if suppose one of you try to change this by some research, then entire chemistry you have to change from here onwards. So what we are going to discuss here is that when you take carbon 12, suppose this is my carbon 12. Carbon 12 is made up of neutron, proton, electron, and other various other subatomic particles. But the mass is responsible due to protons and neutrons only, not electrons, because it is very small, negligible mass is there. So what I am doing it, that there are 6 proton and 6 or let me avoid that part. I am dividing this into 2 half. Then I divide into 4 half, 6 half, 8 half, 10 half, 12 half. So what I have done, entire carbon 12, I divide into 12 unit. Why? Because it is 12, carbon 12, the mass is 12. And one of this unit of this carbon is known as 1/12th part of carbon 12. And this 1/12th part of carbon 12, you can relate it as one piece of bread slice. Bread, you have various pieces of slice now. So 1/12th part is the smallest part, which we referred it as 1U. U stand for unified mass, which is also equivalent to 1 AMU, that is atomic mass unit. So 1/12th part is 1U. 1U means unified mass. It is a nickname for atomic mass unit, AMU. So the 1/12th part of carbon 12 is known as AMU. And AMU, the nickname is U, the representation, the symbol. U stand for unified mass. That's why you see here, this carbon 12 units are there. That's why this needle is upright. It is balanced. So carbon 12, you can divide into 12 part, and one of the smallest part, for example, this, the 12th part is 1U or 1 AMU part. And that small 12th part, you can consider it to be one bread slice. So in this slide, what are you going to remember? I'm giving you a nutshell. I have given you a lot of information here. First, atoms and molecules are too small. You cannot find out the absolute mass. So you are going to find out a relative mass by taking a standard. The standard is carbon 12. Why carbon 12? They are abundant. They are less, their chemical properties are known. Their molecular structures are known. They are generally less reactive. From 1961, we are using them. Carbon 12, I divide it into 12 part, and one of the part of that carbon, one of the piece of the carbon or the slice of carbon is 1/12th part of carbon 12 atom. And that 1/12th is known as 1 atomic mass unit, which is represented as 1U also as unified mass. So please remember this much in this slide. Let's go further. Now, atomic mass, for expressing atomic mass on the relative scale using carbon 12 atom, an isotope of carbon, which is selected as standard and assigned a mass of carbon 12. So we need a standard element with known mass. So we selected carbon with mass 12. Atomic masses are therefore defined as the standard. Atomic masses are therefore defined in terms of standard atom, which is known as atomic mass unit. Okay, so that when I use a standard carbon 12 to find out the mass of another element, I can represent them in as AMU, atomic mass unit. That part is simple. In other simple terms, I can tell that atomic mass is the total mass of the element. Element like hydrogen, oxygen, carbon, nitrogen, sodium, etc. So the total mass of the element, which is made up of protons and neutrons, sum of proton and neutron, that will give rise to atomic mass. And similarly, since our fingerprints are very unique, my fingerprint and Ramesh and Suresh fingerprint, they are never same. Even the iris also. So since our fingerprints, they are same, similarly, atomic masses are considered to be the fingerprint of the element. If I tell that the atomic mass is 12U, it is for carbon, whether you are in India or Uganda. Let me switch off the fan, the speed is high. Whether you are in India or Uganda, the mass remains 12U. So the second paragraph, atomic mass represents the total mass of an atom of an element measured in atomic mass unit. It quantifies the combined mass of the proton and neutron, the sum of proton and neutron. Atomic mass is like fingerprint of an element. Atomic mass, now here basically I'm talking about relative atomic mass, so I'm writing RAM. RAM stand for relative atomic mass. Here in computer also you have RAM. So what is relative atomic mass is, it is a mass of one atom of an element by 1/12th mass of atom of carbon 12. Again, relative atomic mass is what? Mass of one atom of an element, for example, hydrogen, by 1/12th mass of, it's like this. For example, I am taking mass of one hydrogen atom by 1/12th mass of carbon 12. Carbon 12 mass is 12. So what we do, these two will cancel each other. Whatever is the mass of this, you will get it. Okay. Now 1/12th of the mass of carbon atom 12. So this part, the 12th part, 1/12th mass of one atom of carbon 12 is 1 AMU or 1 U. It helped to express RAM, that is relative atomic mass. So 1/12th mass is nothing but 1 AMU. An example, carbon atomic mass is 12.001. 6 proton and 6 neutrons are there. Sir, why it is not exactly 12? Why it is slight more? Due to presence of 15 isotope. 3 isotopes are natural, 12 are artificial and man-made, just for your knowledge. Hydrogen atom atomic mass is 1.0079. Why it is not 1? Because due to the isotope which is present here, that's why slightly the mass is more. So atomic mass concept, I think it is clear to you. Atomic mass in short is mass of one atom, which is nothing but the sum of mass of proton and neutron. They are very unique, just like fingerprint of human. They are also fingerprint of elements. Atomic masses are calculated in relative scale using carbon 12 as the standard. Carbon 12th part is 1 AMU, 1 atomic mass unit, which is also referred as 1 unit. And relative atomic mass formula is mass of one atom of an element. You can take carbon atom, nitrogen atom, rubidium atom, cesium atom, anything. 1/12th of mass of carbon 12, like this. So this part is, I think, clear. Why slight masses are more here? Reason for that, they have isotopes. Isotope is what? Isotope, the cheat code to remember is SANI. What is SANI? Same atomic number are isotopes. So basically they are those things which are made up of same element having same atomic number but different mass number. Hydrogen is made up of protium, deuterium, tritium, like that. SANI, same atomic number isotopes. Now let me give you one more concept here. Initially I thought to avoid, but I feel now you can understand. For example, this is my element. Consider it to be element ELE. And here I am writing it as mass of one atom. And mass of one atom is represented in AMU, atomic mass unit. My third column, mass of 1 mole of atom. And this is known as atomic mass. This is known as gram atomic mass. So in future, you will be confused between atomic mass and gram atomic mass. Let me clarify now itself. Element column, mass of one atom, which is AMU, that is represented as atomic mass. Mass of 1 mole of atom, which is gram atomic mass. So here I am focusing on one atom. Here I am focusing on 1 mole of the atom. Now what is mole at this point of time? You remember that 1 dozen banana means how many banana? 12 banana. One couple means how many? 2 pen. Sachin Tendulkar or Virat Kohli scored 100. So 1 century means 100. Similarly, 1 mole means 6.023 into 10 to the power 23 or 6.022, that I will tell you in future. So 6.023 into 10 to the power 23. This number is known as mole. This number is called dozen. This number is called couple. This number is called century. This number is called as mole. So mole at this point of time is just a number for you. Okay. So element mass of one atom in AMU, mass of 1 mole of an atom. So here 1 atom, 1 mole of an atom. For example, if I take hydrogen, then atomic mass is 1 U. If I take carbon, then atomic mass is 12 U. I'm taking as 12. I'm avoiding the decimal. If I take oxygen, then my atomic mass is 16 U. If you're talking in terms of gram atomic mass, this you can refer it as relative atomic mass also, or atomic mass. This is gram atomic mass. Then 1 U become 1 gram, 12 U become 12 gram, 16 U become 16 gram. What you have done, atomic mass, when you compare with gram atomic mass, the U is replaced by G, that is gram. Okay, but atomic mass is for 1 atom. This is for 1 mole of that atom, just for your knowledge. Just replace U with G, it becomes gram atomic mass. I hope this part is also clear to you. I'm trying to keep it as simple as possible. Let's move to the molecular mass. Just the way you calculated atomic mass, the formula was relative atomic mass. I'll show you again. Relative atomic mass, this was RAM. Relative atomic mass is mass of one atom of an element by 1/12 of the mass of carbon-12. Molecular mass means what? Here molecular mass will come. In place of atom, one molecule will come and the denominator part remain the same. Let's check that out. So molecular mass is what? It is basically the mass of one molecule. Simple term. It is calculated using the sum of all the atomic masses. You take the atomic mass and the sum of everything, add up, you will get the molecular mass. So molecular mass of a compound refers to the total of all the atomic masses of the atom which form a compound. Molecular mass, not relative. Relative also you can tell, but it's understood now it is relative only. So molecular mass is the mass of a molecule of a substance. 1/12 mass of the carbon atom 12. Same concept. There it was atom. Now here it is molecule by 1/12 mass of carbon 12. Okay. Now if suppose I take water, or let me take hydrogen. Hydrogen is made up of 2 atoms here now. So one was one atom of hydrogen is 1 U, other one is 1 U. When you combine, it will give rise to 2. So the molecular mass is 2, the atomic mass was 1 each. Okay. Similarly, if I talk with respect to water, it is made up of 2 hydrogen and 1 oxygen. Mass of oxygen is 16. When you combine them, 2 plus 16, it is giving rise to 18. This is the molecular mass of water. This is the molecular mass of hydrogen. Now let's see this in example. Molecular mass of hydrogen is 2. This indicates that the mass of hydrogen molecule is twice of the mass of 1/12 the mass of carbon 12. What I mean by this, when you take molecular mass for hydrogen, if I'm calculating for hydrogen, you know it is 1 plus 1 is 2. So 1/12 mass of carbon 12. These two cancel, it give rise to 2. If it is gram molecular mass, you take unit as gram or gram per mole for molar mass in future. Molecular mass of water is 18. This indicates that the mass of water molecule is 18 times of that of 1/12 mass of carbon atom 12. So in place of this 2, if I replace it by 18, then 12 got cancelled. It will give rise to 18 gram if I'm considering gram molecular mass. So simple it is. Atomic mass is the mass of entire atom. Molecular mass is the mass of a molecule. They both are compared using carbon 12, the 12th part of carbon 12. Okay. And it is calculated by adding up atomic masses of all the atoms which is present inside the molecule. I hope this is clear. I'll give you examples on this so that concept is more clear. Now let's calculate molecular mass of methane, known as marshy gas. Now, if I calculate the molar mass of this, it is made up of 1 carbon and 4 hydrogen. So carbon is 1 into 12, the mass, and this is 4 into 1. So 12 into 12 plus 4 is 16. So 16U unified mass I can refer. If I am taking in gram molecular mass, then it will be written as 16 gram. 16U or 16 gram. Both are acceptable for you. You can see here. So mass of 4 hydrogen, so 4 into 1, 4 AMU. Mass of 1 carbon is 12. When you add up, it is 16. What are just now I have shown you how to get 18. Now this 18 AMU and 18 U is molecular mass. The moment it is gram molecular mass, which is for 1 mole, the unit will become gram. And in future, you will read it become gram per mole. Okay. So when you take molecular mass, you can refer the unit as U, which is the outdated unit. We don't use much. Whereas gram at this point of time, in future, it become different, gram per mole. This is for 1 molecule, okay, the mass, 1 molecule, and this is for 1 mole of that molecule. 1 molecule ka mass and 1 mole molecule ka mass. What 3 columns I have given in case of atomic mass, no? It was mass of 1 atom and mass of 1 mole of atom. Similarly, it will be mass of 1 molecule and mass will of 1 mole of the molecule. Now let's see a couple of examples and try to solve it. Find out the molecular mass or gram molecular mass only of methanol, sulfuric acid, which is the king of chemical, nitric acid, and SO3, sulfur trioxide gas. Pause the video for some time and find out. In order to find out this, you must know what is the atomic number and mass. Otherwise, you cannot find it out. So pause the video and try to find out quick. I think it's done. Now let me help you to find out. Suppose I am finding out gram molecular mass for methanol. Methanol is that alcohol which is used in alcoholic beverages. If you drink methanol, you dance because you are intoxicated. If you drink, sorry, what I said, ethanol. Huh? If you drink ethanol, you will dance. You're intoxicated. But if you drink methanol, your enemies will dance because you are gone. Ta-ta, bye-bye. It is poisonous in nature. Methanol is toxic, whereas ethanol is intoxicating. But in excess amount, it is also poisonous. You should not drink. Disclaimer. So gram molecular mass, you have 2 carbons, you have 6 hydrogens, and you have 1 oxygen. Oxygen, I'm just putting it a hyphen. Carbon is 2 into 12. Oxygen is 6 into 1. And 1 into 16 for oxygen. So 24 plus 6 plus 16. 24 plus 6 is how much? 30. And 16. 46 gram if I am calculating gram molecular mass. I hope you got this. 24 plus 6 is 30 plus 46. Correct now? Now let's calculate for H2SO4 gram molecular mass. 2 hydrogen, 1 sulfur, 4 oxygen. So hydrogen is 1 mass, sulfur is 32, oxygen is 4 into 16. So 2 plus 32, 16, 32, 64, 4, 5, 6, 7, 8. How much? अयो काय को ऐसे होता रे भाई? 4, 5, 6, 7, 8 and 3, 9. So 98 gram. 98 gram. Are you getting that? Correct. Nitric acid. Jaldi batao. Gram molecular mass. How much? There is 1 hydrogen. You take the atomic mass of all, the sum, 1 nitrogen and how many oxygen? 3 oxygen. So 2 into 1, oxygen is 14 into 1, 3 into 16. So 2 plus 14, 16 into 3, 32. How much? 8. How much? 16 into 3. Quick. 48, nah, correct. So 48 to 50, 64. Yes or no? 50, 64. Correct, nah? Yes. Sulfur trioxide, gram molecular mass. The unit will be G only, okay? Here. Sulfur is 1 sulfur, 3 oxygen. So 16, sorry, wrong. 32 for sulfur and 16 into 3. So 32, 16, 3 ja 48. So 8, 10, 7, 8, 80. How much? Find out. Quick, 80 gram. Correct. So that's how you are going to find out the molecular mass or gram molecular mass of a molecule. I'm telling you again, gram molecular mass is in G. Gram molecular mass is for 1 mole of the molecule, whereas molecular mass is for 1 molecule. And the outdated unit, what is used is unified mass. So that's it, I think. Next will be the question of the day. So find out the molecular mass of all this. When I meet you next class, I will discuss on that. So let me give you a brief. In today's session, we discuss session of the day of the session 2, followed by your mixtures, type of mixtures, homogeneous, heterogeneous. Then we discuss mixture and compound, physical and chemical change. What is the chemical reaction? What is the chemical equation? What is reactant product? What is yield and the arrow and the stoichiometry? What is atomic mass? Why you use relative atomic mass? Why carbon is taken as standard? What is gram atomic mass? What is molecular mass and gram molecular mass, followed by this. So that's all for the day. I think I have stretched it for 10 minutes extra. That's all from my side. So wherever are you in this vacation, do well, consume your time well, and study well. Respect your parent, respect the animals. Be a good human being. Take care of your health. Also do some exercise. Don't use mobile much. It's a modern day drug, not good for your brain. It creates fogging effect and various other things. I don't want to go in detail of that. So respect your parent, love your young ones, and let's meet in the college after a couple of weeks. Tata, bye bye everyone, and God bless you all.